Right. So an important property which is about the number of points required to uniquely determine a circle. The answer is 3. Let's see how 3 points that are non-collinear would uniquely determine a circle. Now, a point A, a point B, and a point C. These are 3 non-collinear points, and I claim given these 3 points, there would be one and only one circle passing through these 3 points. Let's see how. Alright. I join A to B and I join B to C. Right. Then I draw a perpendicular bisector of BC. This is a perpendicular bisector for BC. Of BC. And let me call this point, say, P. I also draw a perpendicular bisector of AB. This is the perpendicular bisector of AB. And let me call this point Q. Very clearly, if this is the perpendicular bisector of BC, BP will be equal to PC. This would be 90 degrees, this would be 90 degrees, right? BP will be equal to PC. And let's say the two perpendicular bisectors intersect at a certain point, call it O. Call it O. Let's say the two perpendicular bisectors intersect at a certain point called O. Now, this QO is also the perpendicular bisector of AB. So then we must have AQ equal to BQ. And this must be 90 degrees, this must be 90 degrees. Now, what I do is, I join O to A, I join O to B, and I join O to C. Right. Now let me compare triangles OBP and OCP. Let me compare these two triangles. This triangle and this triangle. Now in these two triangles, they're right angle triangles. This is 90 degrees, this is 90 degrees, as you can see. Both are right angle triangles. Now in these two triangles, we must have BP equal to PC. Why? That's out of construction. Because OP was the perpendicular bisector of BC, so BP is equal to PC in the two right angle triangles. Also, OP is common to both the triangles. Right? What does this mean? Two sides of this triangle equal to two sides of this triangle. The two triangles therefore are rendered congruent. Why? That's out of RHS condition. Out of RHS conditions, the two triangles are rendered congruent. Right. Now, let me compare these two triangles. That means triangle OAQ and triangle OBQ. OAQ and OBQ. Let me compare these two triangles. Again, these two triangles are right angle triangles, 90 degrees, right? And in these two triangles, once again, do you realize that AQ is BQ? That's again out of construction. AQ is BQ because OQ was the perpendicular bisector of AB. Q therefore must have been the midpoint of AB. Very simple. And then OQ is common to both. OQ is common to both. Now the two triangles are right angled because OQ was perpendicular to AB. So this is 90 degrees and this is 90 degrees. And therefore, out of RHS considerations, the two triangles are once again rendered congruent. Right? Very good. Now, Look at this first condition. OBP, triangle OBP, congruent to triangle OCP. This is what we obtained out of the RHS consideration, which would obviously then imply, this would then imply OB equal to OC, OB equal to OC. Right. Now, congruence of these two triangles, this triangle and this triangle, congruence of these two triangles, that is triangle OAQ and triangle OBQ. OQ is common to both, AQ is BQ. RHS considerations led to these two triangles being congruent, which really meant that OA must be equal to OB. So this would lead to OA equal to OB. Meaning what? If I combine all of this, we got OA equal to OB equal to OC, which means O is a point. O is a point equidistant from AB and C. So this would mean OA equal to OB equal to OC. O is equidistant from AB and C, which means with O as the center and OA or OB or OC as the radius, one could draw a circle. With O as the center, one could draw a circle passing through AB and C. One could draw a circle with radius OA, OB or OC. There exists a unique point O. There exists a unique point O lying on the perpendicular bisectors of AB and BC such that OA equals OB equals OC. Therefore, with O as the center and OA or OB or OC as the radius, one could draw a circle passing through A, B and C. So given three non-collinear points, there exists a unique point O equidistant from the 3 points, leading to the most simple fact, the most relevant fact for circles. Given three non-collinear points, one could uniquely draw a circle as described, right? So three non-collinear points uniquely determine a circle, right? So this property, keep track of this. Let's examine some more in some more time. Thank you.